Good afternoon. We're talking about our similar figures today. So this is our introduction to similar figures. Our similar figures are polygons with the same shape but different size. So they look similar, it's just one is bigger or smaller than the other. And polygons are similar if all the corresponding angles are the same. That's what gives them the same shape. If you look at these two regular pentagons, those corresponding angles are all going to be the same, but the sides are not going to be the same. They're going to be proportional. So I can multiply all the side lengths of one to get the same number as the other. So maybe the side lengths here are 2, and I have to multiply that by 7, my scale factor, to get the side lengths of the other figure. And the ratio of those corresponding sides, the number I have to multiply to get from one figure to the other, that's called our scale factor. And we use k as our variable. If polygons are going to be similar, then their perimeters are also proportional. So if their side lengths are proportional, then the number I get when I add up all those side lengths should also be proportional. And we have our similarity transformation right here in the middle. It's just you take the side, or you take the vertex names, and you would write them such that the corresponding vertices are in the same spot. So B would correspond with F, or H would correspond with D, or A would correspond with E, and so on and so forth. Now, if I look at an example here and I want to find the corresponding parts of these similar triangles, for example, let's start with Z. So even if I didn't have that picture, I could still tell you that Z corresponds with T. And the reason that I can tell you that is because they're located in the same spot. They're the last letter in the name. So angle Z corresponds with angle T. And because they're similar figures, those angles are congruent. They're the same number. Or I could say that angle R, the first letter, corresponds with angle X. Or angle Y corresponds with angle S. And you would find the corresponding side lengths the same way. So RT, that's the first letter and the last letter, RT. That is similar or proportional to XZ. So I'll multiply RT by my scale factor to get the length of XT. Or YZ, the last two letters, I can multiply those by the scale factor to get ST. Or RS, where is it? RS, first two letters, that would be corresponding or proportional to XY. So that's how we're going to name our figures. Let's look at an example. In this diagram, I've got XYZ is similar to RYS. And what's important to note here is that we have a pre-image of sorts and an image of sorts. You know, they're always going to go in a specific order. And that's how we know what to divide by what to find the scale factor. So just like in chapter 4, we had a specific order. I'm going to call this the pre-image, and that's the image. So XYZ is our pre-image. That's our big triangle. And RYS is going to be the image. So I'm going from the big triangle to the small triangle. Okay, so how do I find my scale factor? Well, I can take any side, does not matter which side, of my pre-image. I'll go with 12. I can take that side And just like we did with dilations in chapter 4, I'm always going to take the image and divide it by the pre-image. So my image looks like 8. And my pre-image is 12. And how do I know those are the corresponding sides? Well, xy corresponds with ry, the first two letters. So that's ry. xy corresponds with ry. So 8 and 12, and then if I simplify this, that's 2/3. If you divide by 4, you get 2/3. So my scale factor is 2/3. And why don't you take a minute, pause the video, and see if you can find the corresponding angles just by looking at the letters and matching up what goes with what from the names. So see if you can match those up, and then unpause the video and check your work. Okay, and YXZ, middle, first, last. YXZ goes with YRS. Middle, first, last letter in the name of that smaller triangle. YZX, that's the middle, then the last, then the first. Middle letter in the smaller triangle is Y. The last letter is S, the first letter is R, and XYZ, just in order that goes with R, Y, and S. Okay, so see if you can find out, see if you can find out what the scale factor is between these two figures. Remember, it's image over pre-image. And when you're choosing your corresponding sides, make sure to use the names. So I'll give you DG. DG, what does DG correspond to? And then use that side to find your image length and find your scale factor. Okay, so DG corresponds with PS. So image over pre-image is going to be 1/3. So my scale factor is 1/3. And let's talk about what that means. That just means that if I take any side in the pre-image and I multiply it by 1/3, I would get the side length, the corresponding side length in the image. And that makes sense. I'm getting smaller, so it's going to be 1/3 the size. Okay, and let's talk about our corresponding side. So GF, and the order does matter, goes with R. Sorry, not RS. GF goes with SR. In our very last two problems, we're going to write our similarity statement, and then we'll find the scale factor. So remember, it's always image over pre-image. Image over pre-image. And to write your similarity statement, just find the corresponding letters and make sure that when you name the figure, you put those in the same order. So if I did A, B, C, it would be L, M, and N. And then my scale factor, I can pick whatever side length I want. I'll go with NM, which means that I've got to go with BC, and it's image over pre-image, or 4/3. Why don't you see if you can write your similarity statement in number 5 and find your scale factor? So pause the video, find your similarity statement and scale factor, and then unpause the video to check your work. Okay, so you should be done at this point. If not, pause the video again. JKLM would be similar to N, P, Q, R, and your scale factor is 2. So make sure that you email me with whatever questions you have or join office hours after school. Otherwise, I will see you in class. Thanks, guys.